This is another in a series of tutorial videos on advanced spring design. This is brought to you from Universal Technical Systems and the Spring Manufacturers Institute. This session will cover special topics related to torsion springs. For ASD7, we've added some new features, expanded on the capabilities for torsion spring design. We've also improved the help so that you can get a better picture of what's going on and learn about them that way. I'm going to begin, make a few entries here for design. Notice that as I made an entry in one of the moment arm length fields, the same entry was made in the second moment arm length field, and that happened because of this option up here, equal arm lengths. By setting that active, it equates those two, and that allows the software to be able to back solve for moment arm length given other inputs if we need to, adding to the flexibility. Another feature that we added is computation of active coils based on body coils, or total coils as we call them, and moment arm length. The total coils plus a fraction of the moment arms equals the active coils. It's a rather complex calculation. We feel that most would not necessarily think to input a value for active coils because it's just not going to be something you would know or be able to see from a drawing, that sort of thing. And so what we've done is we've actually blocked the capability of inputting a value for active coils. So total coils can be an input, and your arm lengths can also be input. Active coils, simply for information purposes only, is shown as an output. Make some more entries here. And as I do, you see that the software has done the calculations. It shows the changes to the moving arms angle and the angle between arms as we add loads to the spring, these cycle loads. Moving arms angle and angle between arms are two different ways of explaining how the arms on the torsion spring are related. The angle between arms, that's a new variable that's been added to ASD7. Simply the difference in the direction that the two arms are pointing. That's all. For a little help on this topic, and visual help at that, we can go to the context-sensitive help, and it immediately takes us to a spot here where we get the nomenclature for torsion springs. For virtually all spring types, there's also a section where you can see some design notes related to that spring type. And in this case, for torsion springs, we specifically go through the details on orientation of the arms. You can see here that the body coils dictate both the moving arms angle and the angle between arms. If we have a 90-degree moving arms angle, well, then the body coils must be some fraction 0.25. So 3 1/4, 4 1/4, 5 1/4. The 0 angle position points to 3 o'clock. That's standard. That's the rule that we use for consistency. And you can see that as we have the arms pointing in the same direction, that being angle between arms equals 0, the moving arms angle is 180 degrees. So instead of being pointed in the 3 o'clock direction, it rotates and is now the 9 o'clock direction. So with body coils of 3.5, we get moving arms angle 180, angle between arms 0. A nice summary here. The moving arm angle position is always measured from the 3 o'clock position counterclockwise. The angle between arms is always measured from the 9 o'clock position clockwise. And of course we also get the DXF image as well as those 3D images for these arms angles. We'll take a look at our DXF image for this particular design I've done. And you see that the blue arm, that relates to the free position. So we're at 90 degrees. We have 4 1/4 coils. When we apply the minimum cycle torque, we get the green arm. The maximum cycle torque is the yellow arm, and then the set position, or the maximum stress position, is the red arm. The next feature that's been added for ASD7 is the estimated life plot. Take a look at that. The life plot is based on a Goodman diagram. A cycle stress percentage is computed that forms this vertical line. That stress percentage is compared with the SN curve, the stress life curve. So for this music wire example, at 1 million cycles, the percent of tensile strength is 50%, and at 100,000 cycles, it looks to be at about 53%. So that's the SN curve for this particular example. Anything falling to the left of that SN curve, any stress condition to the left of that curve, would indicate a life of greater than 1 million cycles, because that's this point right here. Anything to the right of that SN curve would be an indication that the life is going to be less than 100,000 cycles. Anything falling along the blue SN curve will be some life between 100,000 and 1 million cycles. So as we make changes to the design, I'll go ahead and increase the maximum cycle torque to 18. You see that that moved the stress percentage over to the right side of the SN curve. In doing so, it changed the estimated cycle life to less than 10 to the 5th, or 100,000 cycles. So as you make changes here, you will get changes to this estimated life plot. That ends this session on torsion springs.